You have to find the time. Velocity is square root ft by mu. Mu is 0.65 by 8, which is 0.08125 kilogram per meter. Okay, so you put it back into the formula for velocity. Find the velocity as 41.5 meter per second, and then time is distance by speed, which is 8 by 41.5, 0.193 seconds. And then when you get the answer, always look at it. Take a second look and say, is this sensible? Yes, it is. Just a small time, you got it. All right, second question. Velocity square root ft by mu again. And I already told you this, but I'm writing it again, that linear density is pi r squared times rho. So when you plug all that in, you get pi times the radius, 0.5 times 10 to the negative 3, because you have to change it into meters, isn't it? Pi r squared times the density. You get that as mu. And the unit is kilogram per meter, because it's mass of 1 meter. And then plug it back into that equation. Ft is mg, that's why it's 50 times 9.8, and it's 267.84 meter per second. Any thoughts about that final answer? Man, it's fast. It is. 267 meter per second is fast. What is the reason? What is the reason why it's so fast here? Isn't it because what? The tension, yeah, the tension plays a big part. If the tension is bigger, the speed is bigger too, yeah. 50 kilograms. And also, its mass per unit length is small. Notice that. Its mass per unit length is really small. That's why it's such a big number. So in this question, intensity is inversely proportional to the square of the distance. Now, when I told you it's I1 by I2 is R2 squared by R1 squared, it was exactly the same thing. It's just that when I wrote it as a product. Do you see that it's the same thing, please? Because when I did that, I cross-multiplied. When I told you, I divided. It's the same thing. So it's I1 R1 squared is I2 R2. So you've got to find I1. I2 is given. Do you have to change kilometers into meters in this case? No, because it's just a ratio, isn't it? As long as you have both in kilometers, that's fine. And you get the answer. There it is, the A part. Shouldn't the intensity be higher at 1 kilometer? And it is. That's how you check the answer. So, all right, at 48 kilometers, it was 3 times 10 to the 6. 1 kilometer away, it has to be bigger than that, and sure enough, we got it bigger. So that makes sense. Okay, power is, if you remember, power is intensity multiplied by the area. Because when I taught you, I gave it to you as I is P by A. Maybe it was P by S in that case, but it is area, right? So power is intensity multiplied by the area, and it is given. So all you got to do is just multiply and get the answer. The unit changes because it's power. All right, number 4. Power. Isn't this the formula for power? 2 pi squared mu velocity f squared a squared. And in this question, what do you have? You have the frequency and you have the amplitude, but you do not have the velocity. So first, you have to find the velocity from tension and mass per unit length with that formula, which we have used. Okay, I just decided to plug it into that formula in place of velocity. Okay. And then it's just a matter of putting in all those numbers. Amplitude is in centimeters. You have to change into meter. That's why it's 0.02. Mass per unit length is in proper units. Tension is in proper units. So that is the answer. Number 5. The frequency is given. The speed is given. Then you have to find the wavelength. Just a matter of substitution. Wavelength of speed divided by frequency, 0.658 meters. I don't understand, man. 360 degrees is one time period. Yes, isn't it? 360 degrees is one time period. Come on now. One wavelength is one time period because it's one rotation. So 360 degrees is one time period. Now, so I'm saying 5 degrees is t seconds. I'm trying to set it up as a ratio. Okay. Therefore, you just divide 5 by 360 is t by t. And then because 1 by caps t is f, 1 by time period is frequency, so I got a formula. 5 by 360 is ft. Now you got to find the time, so rearrange that. There's the answer. This time, because it's talking about distance, 360 degrees is one wavelength, right? And so I'm saying phi is equal to x. Again, set it up as a ratio. 5 by 360 is x by lambda. So phi is x by lambda times 360. X is given. You already know lambda. This is one way of doing it. All right, so from velocity and frequency, you first find the wavelength. And then you know that the distance between nodes is lambda by 2. So since you have the wavelength, just divide it by 2. And I'm trying to explain again that the distance between two nodes is lambda by 2. The first length is given, so you find the mass per unit length, and I changed it into kilograms and meters. That's why you have the 10 to the negative 3 to change gram into kilogram, and 10 to the negative 2 to change centimeter into meter. So it's in kilogram per meter. And then the velocities, this is the 5th time we're writing this, square root ft by mu. Okay, and so you get it as 385.45 meter per second, which is a huge velocity gain. But the question does not stop there. So you first find the velocity, and then you're asked to find what? What are the frequencies of the fundamental and the first two overtones, isn't it? Then you have to know, oh, what's the fundamental? The fundamental is when the string vibrates in one segment. Remember what I told you? One segment. Then you, if the length of the string is given, and then you know that that is how many wavelengths? Half a wavelength. So you set them equal to each other. L is equal to lambda by 2. L is lambda by 2. So for the fundamental, that's what you have. Therefore, you can find the wavelength. It's twice the length. Once you get the wavelength, you can find the frequency using speed by wavelength. So you get it as 321.2 hertz. Which is the vibrating length? 60. And I think I used the 60. You see the 60 here?
Like up on the length of
to find the mass per unit length, you have to use the 90. That's what I've been telling you. To find, because the mass is 3.16 grams for 90 centimeters. That's why I told you 50% missed this problem. And so you have the fundamental, and what's the first overtone? Did I even use the word overtone before? Okay. Did I use this? Fundamental. I did. What's the other word for fundamental?
First.
First harmonic. Yes. Fundamental is also called the first harmonic. Okay, so after that you have the second harmonic, you have the third harmonic, right? And the second harmonic in this case will be twice the fundamental. Third will be 3. Okay, now another word coming in. We need to know these terms. All these are also called overtones. Overtones. Because they're just multiple. So if you see that word, you can either say harmonic or overtones. So be careful. So the first overtone, which is going to be the second harmonic. Don't be confused. First overtone is the second harmonic is that. And the second one will be this. Just multiply it by 2 and multiply it by 3. That's it. That's all. All right. So number 8. Look. You said 0.6. I said 0.3. Why? 1.8 minus 1.5 is equal to 1.5 minus 1.2, isn't it? The difference is constant, and that's 0.3 kilohertz. So 300 kilohertz is the fundamental. Therefore, did we know that lambda is 2 times the length in the fundamental mode?
So the fundamental was 300 and not 600?
Mm-hmm.
I thought it was a multiple. I thought it was 2.
So 2 times the length, we'll come to that because I'm recording, Dilsi. 2 times 0.65, that's 1.3, and then you find the velocity. Okay. All right, number 9. Frequency is the same things that I wrote. Isn't that? Is that what I wrote before? And I wrote something there. Can you explain what it is? That the wavelength does not depend on the mass per unit length. You see the lambda and the mu? They do not depend on each other. You'll understand as we continue. So I made those two constants in this particular problem. Go back to this particular problem, please. What is the only quantity that is changed in this question? Only the tension. So why should we even look at lambda and mu? Because it does not depend on this, isn't it? Okay. I should have said do not depend on F. So I should have said only depends on Ft. Please correct it too. That's what I meant. Only depends on Ft. Because lambda and mu are constant. Therefore, it's just a ratio. If you say it's increased by 15%, what's the new one? If the original is 1, what's the new one? 1.15. So 100 would be 115. That's the idea there. So keeping that in mind, F1 is given, and you have square root of 1.15 because the initial one was taken as 1. Do you see that? The initial Ft1 is 1, Ft2 is 1.15. That's why the ratio is 1.15. Okay. There it is, the last one, 10th one, and this one did not. Okay. All right, the amplitude is there. You don't need the amplitude. Omega is given. K is given. I've put the units also. I'm trying to show you how we get it one more time. That's the answer. 3 meters per second, and you don't need more than 3 minutes to do this question. Thank you so much.